Hello and welcome to the Hydrocarbon Engineering Podcast, where we share short, insightful interviews with industry experts who can shed light on the topics that matter to you and your business. I'm your host, Callum O'Reilly, and here we bring you the first in a series of episodes with Owens Corning that will delve into factors that can support the performance, safety, and longevity of insulating systems installed in hydrocarbon processing environments, including cryogenic facilities. In this episode, I'm joined by Mike Logue, Owens Corning's Global Business Director for Mechanical Insulation. We're going to be talking about important factors such as an insulation's sustained thermal performance, impermeability to liquid, and vapor moisture. I hope you enjoy this episode.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning Foam Glass Insulation. From managing vapor drive and mitigating corrosion risk, to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how foam glass insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/foamglasslng study. That's www.owenscorning.com/FOAMGLASLNG study.
Welcome, Mike, and thanks for joining us today. To kick things off, please can you tell us a little about your current role and responsibilities at Owens Corning?
Hey, Callum. Good morning. So Mike Logue, I'm the Global Business Director for our mechanical insulation business here at Owens Corning. So what that means is I essentially lead the commercial organization responsible for all industrial, commercial, think mechanical piping equipment systems here within Owens Corning. And looking forward to connecting with you today.
Great, thanks, Mike. So let's begin with a clear understanding of the insulating system's function at cryogenic facilities. So what is the primary objective when designing an insulating system for these facilities?
Yeah, so at the most basic functionality, insulation is around thermal control. So when you have a cryogenic system, that's a really cold process, and it's operating in conditions all over the world. So it can be hot, humid environment. So what you're trying to do is control the temperature, not have energy loss coming off of the piping or the equipment, and keeping it at the intended temperature for the design of the operation. There's other properties that you worry about as well. So things like, fire performance, acoustics, there's many other properties, but main goal is thermal performance. That's the main objective of any insulation system.
And what factors can impact the longevity of an insulating system across its service life?
Yeah, so, when you think about a insulation system, they're designed for, to be used and operated passively for many, many years, decades even. And so it really comes down to what the operating process is. So when you're in a cold or cryogenic system, what actually happens is, the mechanical piping and those things actually shift and contract. So think about things when they get really cold, they will shrink up, or when they warm up, they expand. So very, very simple thought process around laws of thermodynamics. And when you have, depending on the external environment, right? So you have a pipe that is contracting and expanding based on its operating procedure. And outside environment, if let's say you're in a hot and humid environment, you would think of like when you walk outside in a hot, humid day with glasses on, you get vapor right on your glasses immediately. Same thing would happen in cryogenic insulation. So when you have a cold pipe in a hot environment, vapor will try and go to the pipe. And so that's one of the things that ends up impacting the service light. It's what we call vapor drive. So hot humid environment will go towards the pipe. And if the insulation isn't installed correctly or isn't the right material, it will not perform. And then you'll have a thermal loss or a risk of the plant not operating in its ideal conditions. Those are the biggest issues that would impact cryogenic insulation system, but normally it's process control and external environment that you're measuring for.
So, Mike, what are some insulation materials that are commonly used for cryogenic processes?
Yeah, so there's a number of materials that get used and specified for cryogenic insulation. One, which is main product that we sell to the space, is a cellular glass insulation. So that's a closed cell, rigid insulation material. Great product, great material, really performs well over the life of the asset. Then other materials that would typically be used would be something known as PIR. Think of it as like a foam, plastic foam type material. Or aerogel blankets are another material, which is like a powder blanket that would be installed. They all have pros and cons to them, but all could be used in a cryogenic piping and equipment system. But again, it depends on the job and the location as to what's going to be the best fit for purpose.
So, Mike, you mentioned earlier the importance of thermal performance, but what other roles does insulation perform in cryogenic processes?
Yeah, so obviously thermals is a big deal, right? So you're trying to control energy, heat loss, and design conditions for the overall asset. One of the things that's probably not fully appreciated is that when you're running an industrial facility, that energy loss actually can lower the yield or performance of the asset if you're not running at the design temperature. So while I think of energy savings as a cost, depending on the process, it can actually also impact your yield or output. So it's not just thermals, it's actually output of the facility. Other things that something that's very common in insulation is fire prevention. So when you think about an industrial facility, they could have hazardous chemicals, they could have, combustible materials or products that are all over the facility. So an insulation system is one of the first lines of defense in a plant, right? So if there was an active fire ongoing at the facility, you want something that won't add fuel to the fire. So you should way to think about it. So insulation systems can be non-combustible. They can actually be fire rated up to certain times. So when you have critical infrastructure or parts of the component, the fire rating and how long it would last are really important to keep the overall site as intact as possible, not add fuel to the fire. Acoustics are another property that we typically think about. So that ends up being how loud the facility is. So when you're on site, when you have workers on site and you need to improve the acoustics, it's really about improving hearing protection for the workers. And if you're, it's one thing in an industrial facility, but in commercial facilities where it's way more population in the area, acoustics end up being a really big thing that we design for to, sound dampening. Last issue that I would face, or not really last, but the other big category is moisture. So as I stated earlier, one of the big issues that we see in cold and cryogenic piping systems is what we call moisture drive. Essentially, this is a phenomenon where moisture in the air wants to move towards a cold pipe. And, one of the things that can happen over time is this, what we call in the industry, corrosion under insulation, which think of it as a stainless steel pipe. If you have moisture operating on the outside of the pipe, it can lead to corrosion and think of it as like leaks in the system. So you have the ability to lose product and make your asset not really perform. It is a huge industry challenge. So we make sure we spend a lot of time talking through, making a system that doesn't allow moisture to get through. That's a big factor that you're solving for in insulation systems. and you really want to make sure you keep moisture away from the pipe at all costs to try and avoid this corrosion under insulation phenomenon, which is very costly to fix and reduces the overall effectiveness and efficiency of the asset.
So I wanted to dive a little bit deeper into the problems with moisture, actually, Mike. Can you talk us through what are the common problems that can occur if moisture gets into the insulating system?
Yeah, so the way I was, what I was talking about earlier is think about this phenomenon. I mean, it's typically known in the industry as corrosion under insulation. So if you get moisture beneath the insulation level, it can actually erode the pipe and corrode the pipe rather, so that you would get leaks of the material that's coming through, and could lead to an active spill, could lead to a safety issue that happens on the site. The other issue is that when you get breakup, if moisture breaks through an insulation, not just corrosion, but in a cryogenic system, what you would see is known commonly as like ice balls. So think about moisture penetrating an insulation. You get a soft spot in the line where you're no longer insulated. You have a cold pipe that you're running, say something like liquefied natural gas. You actually get a frozen spot in the line. So you'll get huge, what they call ice balls. It's again, it reduces your ability to operate the unit. It creates safety risk on the facility. In many cases, when you have these kind of failures, you have to stop operations and re-insulate. So if you identify corrosion under insulation, it could be a massive turnaround, which not only are you not making products, but then you have the cost of doing a whole repair and maintenance job on your facility. It's a very big deal for an owner if you run into that problem.
So I've seen that the term hydrophobic is sometimes used to describe an insulating material's performance. What does that mean, Mike? Does it mean that it will keep the moisture out of the insulation system?
Yeah, exactly. So hydrophobic implies the material won't allow water to penetrate, right? So, example, like, so for our cellular glass insulation, it's a closed cell system. It's hydrophobic. It actually floats. Like if you were to take a block of our foam glass, cellular glass, and put it in your bathtub, it would float on top, right? So it literally will not have any water penetrate the material. That is not true for all insulation products, but in which case you've got to think through things like vapor barriers or moisture barriers or different layers. Adds a lot of complexity to the system, and also creates more potential points of failure when you would install it. Really, back to your question, hydrophobic, it doesn't allow water to penetrate, right? It's afraid of water, right? That's the way it's hydrophobia.
Okay, thanks, Mike. So I also want to talk about safety. And you mentioned earlier about passive fire protection. So I was wondering, how can insulation help to support fire safety at cryogenic facilities?
Yeah, so each facility has its own fire risk, right? So think about, the chemicals that are on the facility, what's being moved around the facility to manage, daily operations of the plant, or what's actually in the pipes. The piping equipment could be a combustible material, right? Could be something that could naturally burn if exposed to the environment. So when you think about the insulation system, you're solving two bigger things, right? One is you're trying to keep everything within in the tank or in the piping, right? So you don't want leaks. You don't want an insulation system which is failing, creating corrosion under insulation, which is giving you another source of flammable material, right? Of something coming out of the asset and onto the ground that could create a fire, right? So the other side of this is that if there was a fire on the facility, right? So if you're in an active fire for whatever, if you have a truck coming by and there happens to be a fire because of the equipment, nothing related to the chemicals or the process that you're running on site, you have to ask yourself, how long would your equipment withstand an active fire site? So we do tests on our material, right? So like we test up to there's an example of a jet fire test, right? Where you literally take a jet fire engine and you shoot a flame directly at the insulation material and you try and validate how long does it protect the inner layer from the outside layer of the jet fire? So basically, how long would it withstand in an active fire? And when you think about insulation, it ends up being one on the piping and the equipment, but it's also on structural supports. So think of like the beams that pipes would be standing on. We will actually insulate the pipe support to ensure that if there was a fire, that pipe support would stay in place, right? Because you're trying to make sure that you keep the whole site facility as fireproof as you can. The other thing that is a little bit unique for our business, we do a lot of work particularly in LNG facilities with what we call our pool fire suppression system, which is basically a patented technology we have where we take cellular glass and modules and put a flotation system in LNG spill containment tanks. There's a great opportunity that if there was a spill, we really help passively contain that rate of vaporization from impacting the broader site operation. So it's actually an interesting side of the installation business is how much time we spend on fire safety for a facility. And we really work to partner with the companies to make sure we provide a solution which, supports fire safety as much as it can.
Thanks, Mike. That's really interesting. In fact, we've recently published an article in the April 2025 issue of Hydrocarbon Engineering magazine from your colleague Justin Brown, which was exploring the effectiveness of fire safety systems for LNG facilities with an emphasis on passive pool fire suppression. So I'd encourage any of our listeners that are interested in learning more about that to download that article. If you already have a subscription to Hydrocarbon Engineering, all you need to do is to log into your account over at our website, hydrocarbonengineering.com, to download your copy of the April issue. So Mike, we talked a lot about the performance of insulation systems, but what other factors should be considered?
Yeah, so the performance is obviously very important, but I'd say one of the things we tackle every day is labor, right? So, and there's two big phenomenons that exist, right? So insulation is typically one of the last things that you're doing when you're building one of these facilities. So it's very important that you have something that can be installed on time and as quickly as possible. So time to install is a big factor that we think about when we're designing systems. And there's also this, a phenomenon that's existing certainly in the US, but really it's all over the world, is the lack of skilled labor in the field. So we spend a lot of time working through training for unskilled labor for doing installations. And we make it known, we work with companies around their design, their specification, and we really, try and partner with contractors to be able to install the system per the guide spec of the of the owner, right? The owner and the engineer that's designed the facility. In fact, and one of the things that's come up, as we've been looking at this, because, an advantage Owens Corning has is we have a very wide portfolio of insulation materials. So we actually have done our own studies or have conducted studies with third parties trying to validate how much time it takes to install a given system per a company's guide spec. And, we've done this with cellular glass, with the aerogel blankets that I've mentioned, these products that exist in this cryogenic space. And we actually published a white paper that we shared at our Gas Tech event last year, and we continue to share with the industry. The results weren't what you would expect, actually. So cellular glass it's a rigid system. So there's a lot of news out there that it's a little bit more complex to install, but there's a couple of benefits to it. One, it's only 2 layers. So you have less usage of sort of what I'd call coatings and barriers in the system versus an aerogel system that's, for the same type of application would be more like 10, 11, 12 layers per the guidance. And what we actually found is there was a huge labor savings when you're following the guide spec of a cellular glass system versus that of an aerogel system. And we had third parties, follow both of the engineers' recommendations, it was really, really eye-opening. So I think, long story short, labor is a huge challenge for this industry. And all of these systems have different designs, have different factors when you're installing them. It's really important that as a contractor or an engineer, that you understand the differences and you look at both systems in an apples and apples way, because it could materially impact your ability to deliver a project on time, on budget, and really for startup, right? That's, if you don't start up a facility on time, it's millions and millions of dollars that's at risk for the client. And so Owens Corning, we do our best to make sure not only do you know about the trade-offs and why this is a better time savings installation, but we also support you with services, with people that are capable of training contractors, which may not have the necessary skills. It's a really big part of our value to the market and something we're proud of to offer to the industry.
So Mike, lots to think about. And I just wanted to pick up on something you mentioned there about how Owens Corning can support the industry. So how do you go about doing this with engineers who work on cryogenic insulation systems?
Yeah, so we have a couple of things. So we have a team, we have a technical service organization that's, that we partner with, that on one hand, we do a lot of work of design and specification work. So for these cryogenic systems, we have our own guide specifications of what we would say, which includes things like fire ratings and, expected, heat loss calculations, energy calculations for whatever the application would be. And we share those with engineers, so they ultimately use them in designing their own insulation recommendation or what they're actually going to be building out in the field. We then have we have a training center where we bring together both engineers, companies that are doing these design, as well as insulation contractors. So people that are going to be out executing projects in the field. And we have a training program that we would put them through. We actually not only have a classroom center where we can do it at our, we have a training center in Houston, Texas, but we also take that out on the road. So if you have a job site that's going through and doing a large installation, we can provide site level services and training, as well as, help people see tricks of the trade in order to install as efficiently per the guide spec as they can. It's really important because these are big, large facilities with hundreds, of people, thousands of people that are doing application of the installation. And you really want to make sure you train them up to understand how to install it correctly, because once you operate, certainly in a cellular glass system, the goal is not to have to touch it for years or decades, right? We have some facilities where we've installed something and it operates for 50 or 60 years, right? Because it was installed right the first time, right? If it's installed right the first time, the lifetime of the system can be very long, much longer than what would be expected. So providing that service to our customers is really important, right? Really important to make sure that they have a successful installation.
Great. Thanks, Mike. Really fascinating stuff today. I really appreciate you taking the time to join us for this. Where can our listeners go if they want to learn a little bit more?
Yeah, so easy place, you can go to our website, so www.owenscorning.com. And specifically, if you want to learn more about the different material testing, it's owenscorning.com/foam glass LNG study, which will provide the video, show you the time study we used. That was actually done with, third party insulation contractors following a standard customer's guide spec in the field. We can give you all the stats there, but it's a good example of what I'm talking about. It really helps visualize it for you. So that'd be a good place to get more information.
Great. Thanks again, Mike. Really appreciate your time today.
Yep. Thank you. Happy to be here.
My thanks again to Mike Logue at Owens Corning for speaking on a range of different factors relating to the performance of insulating systems in hydrocarbon processing facilities. We covered a lot of ground, including thermal performance, the problems of moisture, and of course, safety. As I mentioned in our discussion, you can read Owens Corning's article exploring fire suppression for LNG facilities in the April 2025 issue of Hydrocarbon Engineering, which is out now. If you already have a subscription to the magazine, simply log into your account over at our website, hydrocarbonengineering.com, to download your copy of the issue. And if you are not subscribed to the magazine, we'd like to offer you a free trial today. Head over to hydrocarbonengineering.com/magazine and follow the simple on-screen instructions to ensure that you never miss an issue. Thanks for listening to the Hydrocarbon Engineering Podcast. Subscribe for free wherever you get your podcasts. And if you have enjoyed this episode, please rate and review and forward to a colleague or friend.
The Hydrocarbon Engineering Podcast is brought to you by Owens Corning Foam Glass Insulation. From managing vapor drive and mitigating corrosion risk to maintaining thermal performance and supporting safety on the job site, the insulating system plays a critical role in high-performing hydrocarbon processing facilities. Learn more about how foam glass insulation contributes to the design of high-performing insulating systems at cryogenic facilities at www.owenscorning.com/foamglasslng study. That's www.owenscorning.com/FOAMGLASLNG study.